Hello friends, this is Mainav from Civil Center and welcome all back to our channel. So friends, in today's video, we'll talk about a very important topic that is lapping in beams. In which zone should you provide the lapping in beams? We'll explain that with the help of Tekla structural design software and also with the logic so that you can remember it when you execute these structural drawings at the site. So first of all, I'll just share my screen and then show you this is a model in the Tekla structural designer software. And we need to go here to the results view, and after going to the results view, we'll turn on the results and we'll take any load combination or loads. So I'll just take a simple load combination of dead loads and live loads, let's say. And after taking that, you can turn on this shear and also the moment. So I'll go for the moment here. Let's see how the moment is acting here on the beams. So as you can see, if you have also studied for the moment diagram for the beams, you also have seen something similar. So as you can see in the top, at the top, the maximum moment is at the junction of the beam and columns, and it is a little bit more at the continuous end, and it's a little bit less. So as you can see here, for this end, it is the discontinuous end. Also in the discontinuous end, the moment is a little bit less, and the continuous moment is a little bit more in comparison if you compare. But overall, you can say for the the general terms, you can say that in the top fiber of the particular beam, the moment is more at the near the supports, and in the bottom fiber of the beam, the moment is more at the center. So before going deeper into that, we'll just know certain logic, very simple logic for the lapping, and we'll just give a very brief overview. So if you see the cross section of the beam goes like this, let's say, and can make arrangement here. Suppose the beam goes like this, and we have a few columns here like this. We have columns here, and have columns here. So the reinforcement of the beam, will go, the bottom rebars will go like this, having some cover at least 25 mm. Cover is provided in beams, and the top reinforcement will go, suppose this will go like this. Still Control Z and select this, and so it will go like this. It will go like this, and if it goes like this, the lapping is to be given. So why this lapping is given? So if you purchase the coils of rods from the market, it comes in a U shape like this. It comes in this shape. So total length is your 12 meters. So we'll cut and provide the reinforcement at the site. So if it is the case of the lapping of columns, sorry, beams, it occurs like this. So there is one bar and there is one bar at the bottom. So like this, lapping is given, and this particular length from starting from here to here, this is called the lap length, which is generally taken as 50D for both compression and tension. You can provide different for compression and tension, but it is written in your structural drawing. In general, 50D is the maximum value. So just to assume, just to have an idea of how much this value is actually, 50D is the 50 into diameter of the column for 16 mm bar, which is commonly used in beams and columns, 16 and 12. So 16 mm bar, 50D is 50 into 16, which equals to 800. So 800 mm, 0.8 meters. 0.8 meter is the 50D, and if you just for 50D for 16 mm, 16 mm, and for 20 mm, 20 mm it is around. So I'm just giving this idea because so that you can have a practical overview of this. So for the 20 mm, it is around 1000 or 1 meter. So it varies like this. It can be between 0.8 1 meter. So it can be, the lap lengths can be in between that. And for the column, I have made a separate video on the column also. Column lapping is done like this, and here, and even here like this, and then we have some joggle like this. You can have some joggle here and here. So this kind of arrangement is given in the columns for the lapping. So this is done in the columns, but in the case of your beams, we provide it like this. So this length is provided. Where to provide this? Now, as you can see, let's discuss for the top portion first, and before that, let me discuss about the cross section. So if you just see the cross section, there are minimum 4 bars in a beam. There can be more. So if we just represent this 4 bars in this particular cross section, after the cover, it will be like this. It is like this and like this. I should have drawn the stirrups first. So there are the stirrups like this. There is a stirrup like this, and there are the remaining components like this. So it is like this. This is the arrangement of the particular, you know, main reinforcement in our beams. So like this it is arranged, and if you have 4 beams, 4 number of reinforcement, 2 at the top and 2 at the bottom, the zone for your bars at the top should be how much, that will tell you. So definitely by the bending moment diagram, which you have seen here in this particular software, I will just show you the screen. You can see here, this is the bending moment diagram. You can also see from the load analysis view, and right click and open the load analysis. You can see the entire, you know, bending moment diagram like this. Definitely it won't be at this end, it can be at this end. So in general, it is, if you divide the particular span, what will do, divide the particular span into 3 parts. Divide this particular span into 3 parts. Let's go here. Suppose this is the span, divide it into 3 parts. 3 equal parts you can divide. So just so that you can, if this is given as the structural drawing, is good. Otherwise, you can take this. So it's L by 3. And this is L by 3. All these are L by 3, actually, L by 3. And this is L by 3. So like this, if it is there, all the arrangements of the different, divide the particular beam into 3 different spans. So in this particular span of this L by 3, you can can't provide the lapping. Lapping you can provide in this particular span. So here, we just mark here. So this is a zone for the top reinforcement in which you can provide the lapping. You can start the lapping, and if you are having like 4 bars, so 2 bars lapping you can give here, and 2 bars you can give in this next span. So suppose this is the column, beam, and we are having the next span here, and 2 bars can give in the next span. Suppose this is next span, this ends here, and the remaining 2 bars you can give in this portion. So you will have the staggered arrangement. We will not give lapping, all the lapping in one place. So this is the, if you conclude that for the top reinforcement, the lap zone should be at the center. You can divide the particular, L or the length of these different spans into 3 equal parts, and in the middle part you can provide the lap. So if you provide 2 bars lapping in one span, you can provide 2 bars lapping in the other span. So like that you can maintain the staggered lapping, as well as you can maintain the suitable lapping zone. So now the different, now where to provide the lapping zone in the bottom part. For the bottom part, lapping zone, you can just divide it into, further into L by 4, and, L by 2. So L by 4, and L by 2, you can divide it into 3 equal parts. And definitely you can see from the diagram which we had shown you earlier in the Tekla software, that in the bottom the maximum reinforcement is in this particular L by 2 region. So definitely we shouldn't provide any reinforcement or any lapping, not reinforcement, any lapping in the L by 2 region, because this is the most susceptible to moments. So we'll avoid this region. So how to avoid this region? So the logical answer to avoid this particular region would be to provide the lap in this L by 4 region and in this L by 4 region. But suppose let's take a practical example. Why I'm not suggesting to put here, and we'll just take with the help of practical example. Let's see. Suppose a default span, we have a span of, let's say, 3 meters. Span is 3 meters. Because I'm explaining, then I'm saying, otherwise it won't be clear that why is it 3 meters. We are using 16 mm dia bars. Okay. So let's see what is L by 4 here. L by 4 is equals to L divided by 4. 3 meters, I'm taking 3 meters general span. 3 meters is approximately 10 feet. So it is general span which is present between buildings. It can be more also. So it's L by 4. So L by 4 is equal to 3 by 4. It becomes 0.75, 0.75. Okay. So now if this is 0.75, if I have to provide the lapping in this particular zone, if I am using 16 mm die bar, then how will I provide in this particular zone of L by 4? Not possible. No? It will shift to this particular zone of L by 2. Similarly, if it is if it is a 20 mm bar here, then also we cannot provide this in this particular zone. So in that cases, it is best that we provide the lapping for the bottom bars in this particular region. So if we start from this, column and beam junction, then we'll end up lapping will end. So let's say lapping here, it will end in this up to this particular zone. If this is the 1 meter, then we'll get an additional of at least 250 mm here. So this 250 mm will cover the total length deficit. So for the bottom zone, we can provide lapping here and also here. So starting from the beam and column junction up to L by 4. Because for practical purposes, we have to consider this. So in this zone, as you can see, the moment is for the bottom span for this bars in this span, as you can see from the cross section, for the bottom fiber of the beam, the moment is less. So we can provide lapping at those places. So these are some common mistakes which many civil engineers, or not civil engineers, actually many people make at the site. So as civil engineers, it's our responsibility that we provide all this lapping correctly. You can also check out my video on lapping of columns, lapping zone of columns, lapping zone of beams is very important, because once the structural engineer designs the site, the duty of the site engineer is to check those particular drawings and execute those particular drawings properly. If it's not done, then we won't achieve full success of the building. So hope this tip helped you, and this tip will also help you in interviews and also when you execute your works at the site. So happy learning, keep learning, and hope all of you are safe and sound. How are all of you doing? You can let me know in the comment section in this COVID time. How is your family? Everything all good? And you can just let us know below, because this is a part of our YouTube family, and we get to take care of each other. Thank you. Bye bye.